So we are waiting for the answer from Chris, and everyone. Now the question is not for Chris, it's for the whole class. Remember that if you answer my questions, I tend to favor you. Kakra. Kakra, be not too much. So,
okay.
How to express comfortability from a physics point of view, an engineering point of view. When a driver is driving on a vertical curve, negotiating a vertical curve, what really is comfortability? What is it in terms of physics? Forces acting. A centrifugal force. Exactly. So this one, it's not pulling it's not wheeling, but either pulling. Exactly. Pulling it. Exactly. There are two forces acting. One that's trying to get you to the center. There's one that's trying to take you away from it. Are you okay? And so when we design, we need to take into consideration these forces. Now, what it really means is that the speed, we should have a design speed. Are you okay? So for the design of our curves, there should be a design speed. So you should consider design speed when you design our curves, vertical curves. So the proof of the formula, which we are going to look at, I'm going to put one formula on the board, but I'll put a diagram first. Formula so that we understand. I think there's no need for this diagram. I think we already put it on the board. There's no need. All right. So let's look at the formula. Oh no, let's do that. Let's look at the diagram. Let me put the diagram on the board. This is my 360 laptop that allows me to just carry it. Those online, you can't see me, but don't worry. Just watch the PDF, okay? You like it? I'll sell it for you. I'm from Kumasi. Oh, this one I got it for 3,500, but it's more expensive than that. You can get it for like 6,000 now. Yes. Anyway, let's stop talking about the price of my laptop because I put a video online and then someone replied and said, "Stop your students from making comments like that." On a funny note. Anyway, it's not a big deal. I've not even replied. It was this lady and she was just enjoying the class. She said, "Yes, sir, yes, sir." And normally on social media, people can get irritated, isn't it? For no good reason. Alrighty. So P is a gradient, P percent. Okay. This QL 100. So this point, call it C, call this point A. This is C. So those online, the diagram there is being drawn, okay? Take note of that. B, that's A. All right, so this is X. Subscript S. Doesn't matter. X is X. So if it's symmetrical, this is L, this is L. From here to here. Okay. What's going on? Okay, so this is Y. I have no battery. I need to really put it down. Okay, so I'll repeat the same diagram. So the diagram figure 11.23, those online, is being drawn. So B and D. So it's the same diagram being drawn
like twice. Okay, so we have this. We've already drawn it, but I like to repeat myself sometimes. A, B, this is E, C, then H. I think I've touched on this before, that this is the height, okay, of the driver above the ground from the car. So the car may be taller. So in that case, you take the average height, or maybe the maximum height that you can have, tipper truck or something like that, or VIP bus. So in exam, you want to twist it, you just start, you don't even talk about age, you just talk about the height of a driver. Are you okay in a VIP bus which has this height? You know, like remix. Percent minus Q%. Okay, so now this is the S. So I think we've explained this. This is a nicer diagram that we have in our PDF. Okay, so by now the students should understand these two diagrams and be able to interpret it. The only thing that is different I've added to it will be X and then Y here. So it's some kind of coordinate system, in which the tangents are actually being used as certain X. So that's the X. And then the Y value can be established for perpendicular to that line. So it's an offset. So Y is the offset from the tangent. It goes straight down. All right. Okay. So now let's look at two formulas and then let's move on and talk about areas. So let's take note of that. Okay, so what we say S is equal to L is one scenario. S equals to L is a scenario where we have the side distance equal to the length of the curve. Let's say that way. So S equals to L. It's one case. It's one case. Okay, so Y, you can just write Y is equal to B plus Q X squared 400 L. So this relationship is true for this particular scenario. Okay, can establish that. Excuse me. We can also establish a relationship between S, side distance, and L, and then H, and then P plus Q. So S is equal to L plus 400 H over P plus Q. So that formula can be established. So we have, so the second case is where side distance is longer than the curve, okay? We can have that case as well. So S squared to L plus 400 is, this one is the second case, okay? Second case. Well, let's just take an example for the second case. And then that's it. Why is it the second case? That's a question to you if you understand it. So I'm going to give you values. Tell me why is the second case. So P equal to 1, Q equal to -1. Okay, and then you have H equal to 1.05 meters. Why can't it be 100 meters? So I can ask you a few questions, maybe before the questions. Right? Why, if you see 100 here next time, why do you think there's a problem? So a student should understand that. Once you don't understand, you don't understand anything I'm talking about. Why can't this is like catastrophic? Catastrophic.
So,
now you get it. I'm sure you got it. But the way you are talking now, realize. Why? Now tell us.
H is the height of let's say the vehicle.
The human being, what is that? So it is 100 meters. Yeah. You see how it can be fun when you understand it.
Okay. It's a steep environment.
Okay, given this, calculate L. Calculate L. So we're going to use the formula L. So we know H, we know P, we know Q, we know S. Simple, isn't it? And the equation.
So S is equal to 4L.
S is equal to 4L. The equation for offsets. Equation for offsets. From, of course, from the gradients. Are you okay? To the tangents. The tangents, the gradient of the tangent. Get it? So like when we say gradient, is actually which is actually the tangents. So let's see. Offsets from the tangents. Okay, so
Offset from is the Y.
It's
the Y.
The offset is the Y, yes. So now, why is this? We have three cases, isn't it? A case where the side distance is longer, where it's shorter, where it's equal to. Wait, which one is this one? Why?
Which one?
Which of the three cases is this question? Why? Also look into the question. The answer to it is inside distance. The things here contain the answer. Normally, the funny thing is that the answer is in the question. So any good question has the answer. Look at the values one by one. See what is so what is P is what? The left hand slope.
Yeah.
Right hand is negative. Okay, so it's looking like this. All right, H is a high, we don't have a problem with it. So normal. All right, this means this one's like some kind of something, guys. Like I want to be, let's think that way. All right, now let's come to S.
This is 4. 4. It means that.
So this actually means
so it's equal to okay. The side distance is equal to
it doesn't make it just like means that
means that the side distance
longer than
it's
supposed to be 2L. Now we have extra. This is long. Then we put in that formula, calculate L. L then is equal to S minus 400 P plus Q. Now remember that this is actually an algebraic sum. So we are looking at the value of P. We are not doing 1 minus 1. So here we are looking for the value for P. That is but the formula has been proven based on this scenario where Q was negative. Are you okay? So even though you are seeing Q, don't go and put negative. Put the value of Q to 1. Not the value of P. It's actually 1. So you're going to have 1 plus 1. It's a way the formula. You didn't prove it. If you are proven it, that against it. You are not. This one is for you. Ask why the person who's done it, someone to place pinky for you.
so the negative.
So we're just going to have 4L. So S going 4L. Okay, so we have to actually make L the same as minus 400 Q plus Q. So if you make L the same, what we have, we take this other side, bring this one here, then we get 3L. So we have 3L. We have this one on the other side. You understand? Make L the same.
Is that S is equal to 4L? And is that 3L is equal to X minus 100? And PQ. That's
P plus Q.
yes. In that case, where you see X in the actually is 4L.
When you see what? S, you put 4L. So that's why I put 4L.
Right? It's supposed to be at the behind.
When you change it, that's
Okay, so
why
this is how we start, right?
is positive.
Y equals 2y equals y squared plus b, and saying that b is equal to 2a. When you see b, put 2a there. Maybe you don't know b, but since you know that b is 2a, you know a. So in other words, the formula then changes. Like if you are changing the formula, but then no. It's just a question that is just playing with you. Instead of putting, say, a value like red, people ask questions, you should wait, that they ask you like questions. That those are very funny questions. This one is one. So literally we substituted S for L. And then when we did that, we realized that L we need to make the other side. And then we know the value for, so here we don't even think about this formula. I understand. So in other words, we can actually put 4L here. That's the same. That's what you got. That's what you got. I rather did it this way, and now put it back here. And now. They can't even hear me. Yeah. Sorry, okay. Sorry. Online, doing online doing that. I think we need to pay twice, isn't it? Because we are playing the role of like IT person. Like we're not getting that support. IT support. Okay, guys, sorry, we did an example. What you see on the board, yeah, Gabriel and Felix. I'm sorry that I've not been very nice with you. I think my second lecture, maybe I'm just still waking up. I'm heating up. I'm always nicer with them. Yes. So we just put them in, and then basically we get the answers that we need. Okay. All right. So the y is this one. So 1 plus 1. Rho L, the value from 4h on 0 5 over that's 6. You can then use your calculator to calculate the final value. Okay, and then bring it into this equation here. Okay, why don't you punch it and let's see what it is? Somebody punch it in. Those online, you already seen it. Don't punch it. You've seen it.
So the figure 400 points.
It's 100 times.
Time, sorry. I've been talking to a German. They put one there like no, sorry. They put comma for dot and all this kind of things. Oh, but sometimes when you see dot, it means times. Yes, it's not. It's really
1.0.
a primary school people don't understand. They fight you. I have a certain niece, and she always, but that's what it's just like. Doesn't matter what you say. Teacher, a master didn't say that. So what are you saying? What are you getting? You're getting what? So that's correct. 17. So if we're to do the dimension analysis or whatever, I mean, look at it. That still have in units. This has meters. That's it. So the meters inherited from this. So that's where the units. And as an engineer, you always have units associated with meters. So you can picture how this pairs. If you don't have stability, it's not something that very long. I agree. So you have centimeters and another one. That's a lot. From the stretch. 140. Okay, so please guys, let's leave it here. It's okay. I'm trying to cut a lot of things off, but take these 3 scenarios, understand how this calculus works, make your life easy. Let's touch on areas and then close the class. Okay, I believe you all know areas. Let's have a question, please. I'm gonna hurry. Ask me. Areas is gonna be fun, isn't it? But you know it already. You know it. So we are coming to the end of all these lectures. In the next 2 weeks, 3 weeks, or I mean, the next 2 or 3 meetings, we are running out. The hardest part of the lecture. Okay, what's the area of a rectangle? I think we're very fast in saying that. Okay, let's take it forward. Let me just, for the online people, let me just get to it. But I think these things you know already. Why are we even teaching? They are the basis for calculating the volume. And volume calculations are so important because you get paid per cubic meters. Most people get paid per.
That's what you use at the same way to make it.
We can't hear you. Are you contributing to the class? You are going on YouTube. Let's hear you. It's being recorded. Is it not? Yeah. So what are you saying? Say it again, please. Because this will come in. What we just discussed is part of the course. What we just discussed, it will come, but it may no, it won't come. Did I say it?
It will come because we now know the kind of.
Oh, don't trust me, okay? I'm like that too. Maybe I'm changing. These days when I see something, I do it. Hey, where has it gone then? Areas. Here it is somewhere. Okay. How do you work out the volume of a cube? Online, you have 10 minutes. Please rejoin for the last time. This will be the last time you join. What's the volume of a cube? How do you do it? Let's use that as a basis to understand like why we are doing what we are doing. Yes.
The length and the breadth and the
Yeah, it's equal.
Mhm.
Elsewhere, that's
Okay, so like what you said, we have the area. And so mathematically, we have this trigonometry, this area, which is actually squared or something as a unit, which will multiply over. That's what we call it. See, we have heights, so which one gives us how many of these legs last time space. So we create a integrate these small elements. We now have total area. So this is integration. Right. The same way you can see the volume as layers of this piece here. Let me see that. When we simply have each of them within this space. Are you okay? And it can be it's a real number. It's not like it can be 200.222. Are you getting that? So it's quite mathematical than you think. Are you getting that? But the simplest way to look at it is multiplying it. Are you the area by so many a length. This is how simple it is. And if you understand it that way, you now understand why we are doing this in this session. Area calculations are based on working out volume calculations based on calculating the area and literally multiplying by a certain length. The challenge we have is that the real world doesn't conform to these regular systems. That is where the story now turns up. Are you okay? Okay, then let's reconsider. Are you okay? All right, but how can you work out area when you don't understand it? How can you work out volume when you don't understand what's area? So the basic calculations, I think we can skip them. You should know that acres between meter squared and acres, there's a conversion factor. It's not working sign. You just multiply it. Are you okay? To reduce it. Acres to hectares, same thing. You need to multiply by a factor. Meter squared by. There's all these conversions are there. Are you okay? You can go online, go to Google. They have it there. Just type convert hectares to and it should be there. Just put in the value, get the equivalent. All right. So the area for the basic shapes are very easy. Let me look at the triangle. What's the area of a triangle? Isn't it? It's easy and fun. It's like a song that we sing. Yeah, but don't forget this. That height you're talking about is not just any height, it's just height. And you say that's the height. It has to understand that a projection of this one is A, this B, and this is C. So it's a projection of B to this other side of the triangle. So depending on the shape of the triangle, maybe sometimes notice this work out from that triangle. We have these. I'm lecturing. Do you feel I'm lecturing? I said that sometimes this formula may not work simply because you just cannot have this condition. Think about it. It can have a very funny triangle in real life. Look at it. Where your project is, we should put the right angle triangle. It's not working. So then let's just do it. You know what I'm saying? So basically, we need to understand that these formulas have limitations simply because of the real world. It doesn't conform. Triangles and circles there exist out there. Sometimes you can only put in half a circle to make something work. We all know that. Okay, so as simple as the formula goes, there are other ways to actually look at the area. We can actually do it this way. We can do S equal to first look at the S equal to A plus B. C or 2, then use the value. So where A, B, C are the sides, opposite sides of this. You see how I put the ABC? It's like the opposite of the point is okay, so A is the point, B is the point, in capital letters. Okay, so A denotes this. So don't put the zeros there. You have to draw this. And just because of the trend, that's why. Also, don't draw a funny car if you want to draw a car in exam. Draw it in a very scientific way. Someone do and keep lights, headlights. Okay, so we can have area equal to square root of. Like my square root sign, don't you? S times S minus A. This formula, I've used it in my app. Go and look down it. And it can give you the area of the triangle, and it's because it's using this. Okay. Go on Google Play. I'm not advertising my app, but I'm just saying that if you want to see it, okay. Assume that this formula will work for a lot of scenarios. It doesn't always work for all scenarios. There's a particular condition where it doesn't work. So that is how it works. We can have alternate ways of calculating, but at the end of the day, for every shape, there's a way to find the area. Now that one is looking very funny, isn't it? How do you find the area of this one? Are you okay? All right. What you do is that you break down the whole thing into different shapes that can fit. So that's one option. And so Chris here is saying that you can actually create this irregular shape. Okay, online people, you can see it. I'm looking at my letter, I'm still allowing it. He says I can put in a number of squares into this figure. All right, so if you were actually going that way, you could just put in a lot of squares. Are you okay? Of the same size, and count the squares. Are you okay? And then if every square is 1 meter square, then obviously the number of squares counts. Are you alright? And then we are now left with few, areas that can be triangular that you can use to do what you can have a triangle. But these are all approximates and they may not be that accurate. Okay, methods of calculating the area. So this one is not a great formula that you should be considering, but we are looking at it from an intellectual point of view. That is a way of calculating the area of a very monstrous, fuzzy-looking shape. Are you okay? Alrighty. Let's move on. So the next thing we want to look at is calculating the area using coordinates. I believe you guys are very comfortable with this one because you love coordinates, don't you? All right, so if you have an area, if you have an area which is actually defined by, that's right, put it, that's not somewhere. Oh, so close and yet it's kind of funny. Okay. So you had a sheet which was defined by surveyors when they pick some points. A, B, C, D, E. So we have the coordinates. System surveyors pick your boundary. You say you own this piece of land. First, you do what we call traverse. Okay. And from the traverse, you can compute coordinates. The coordinates always come in the form of distance and ordinance.